What is dark energy? Why is it such a mystery today?
Well, dark energy says that empty space has energy. Empty space weighs something. There's nothing there, but it has energy. So don't you think that's pretty mysterious?
Yeah.
Well, it's not only, it's actually, it is mysterious when you say it, but it's more mysterious. But you have to know a little bit more to realize how mysterious it is, because it turns out once you allow for quantum mechanics, it's not too surprising that empty space could have energy. The quantum systems always have what's called a ground state energy, and it's often non-zero. But what's really surprising is that the universe has empty space as energy, but it's so small. It happens to be the dominant energy in the universe, but the energy of empty space is less than 1/1,000,000th of the. So in our galaxy, the average density of matter is 1 proton per cubic centimeter, and in empty space it's 1 proton per cubic meter.
Mm-hmm.
And the energy of empty space is much less of that than the energy of the random amount of matter in our galaxy. Much less than it. It's so small that we never knew about it, and the only way we can measure it is by looking at the universe as a whole. We can't measure it in laboratory experiments. It's just so small we can't see it. Smaller by 30 or 40 orders of magnitude than we can measure now in laboratory. I hate to say the word ever, because I've learned that experimentalists are smarter than you think. They just look. Anyway, no, that's a joke. Anyway, so we need to use the universe as a whole, and it's only observable on the scale of larger than clusters of galaxies, where matter is so rarefied that the energy of empty space begins to be significant. And it's well, in natural units that, and I'm not going to explain what those are, but in the kind of unit, if you think of the scale of particle physics, particles and their masses, the energy of empty space the energy density of empty space is anywhere between 60 and 120 orders of magnitude smaller than you might have expected based on the other scales in nature. So the big surprise is, first of all, that it's not zero, because we always thought it was zero, because that's a good number. And it also, if it was zero, then it would explain why we never saw it. And then we discovered it wasn't zero. Some of us proposed it wasn't zero, and then it was discovered it wasn't zero. But the number is so small that it's ridiculous. It's smaller than, in units of the scale that where you might think it would be, it's 10 to the minus 120. That there's no other quantity in nature that in any kind of sensible set of units is that small. And so we don't have the slightest idea why it's there, and we don't know why it has the value it has. We don't even know if it's fundamental. We don't know if it's what's called a cosmological constant, which Einstein predicted, but he didn't know why he predicted it, really. But quantum mechanics predicts a cosmological constant. Maybe it's some fundamental vacuum energy of empty space, or maybe it's just some energy in some field which is going to go away tomorrow. And there's lots of ways it could go away tomorrow. One of the ways it could go away tomorrow is there's a phase transition, and then everything I see behind you and everything, all of nature that you now see will disappear instantaneously at the speed of light, so you won't know you've been hit. Or maybe not. One of the theories I proposed, I was very happy to save the universe, gave a way for dark energy to disappear without causing much of a ruckus. But the theory is probably wrong. But I think it's most likely that it's the energy of empty space. But we don't have yet, there's no evidence. Well, I shouldn't say there's no evidence. The big question is the energy of empty space changing? And I bet a number of people, I've bet my friend Stephen Hawking and Frank Wilczek and other people about when it was first discovered, that we wouldn't know. There's no experiment that would tell us in the next decade whether the energy of empty space was fundamental or not. And even though, Stephen's died, but Frank denies that he took the bet. But they did. And there's been no experiment that could tell us that. And now it turns out this last year, some new observations have given a tantalizing suggestion that maybe the energy of empty space is changing. But the experimental data is unconvincing, and also the way it's changing seems ridiculous. So my suspicion is that like many things, the first time you look at something very difficult to detect, you get it wrong. Usually, the first time most experiments measure something, they get it wrong, especially if it's hard to measure. There's no theoretical explanation of it, and there's no experiment so far that can tell us anything about it, except that it's there. And that's pretty mysterious and frustrating at the same time.
Yeah.
I suspect we need to know something about quantum gravity before we can resolve this issue, and we don't have a theory of quantum gravity.